Hello everyone and welcome back to my channel. In this video, we are going to see how we can automatically generate the timestamps from a YouTube video. So here we have our YouTube video and our goal is to automatically convert the YouTube video into respective timestamps where each timestamp represent a change in topic and then also name those timestamps up in a proper way. To do this task, we are going to use Cross-Encoder and the Llama model. So to start with, we have our YouTube video and we are going to convert this YouTube video into a transcription and a transcription with timestamp, which we also call it a subtitle. If you do not know how do we convert this video to a transcription, then I highly recommend you watching this particular video of mine. I'll link that in the I button as well as in the description. For this case, we're going to use the Whisper model from OpenAI, where you can do the transcription of more than 99 different languages. And once we have generated this transcript can be pretty long. But one thing right now, why not just use this in ChatGPT? We can just copy this and paste it in ChatGPT, and as we paste this subtitle, it also has timestamp. So ChatGPT should be able to give us the respective answers, isn't it? So that's exactly what I did. I copied and pasted the entire subtitle along with the transcript in ChatGPT, and I get that the message is too long. And it often happens. If your video is short enough, then of course you can get away with it. But for longer videos, it's not possible to use ChatGPT. What you can do is you can divide it chunk by chunk. For example, you give a certain part of it, then another certain part, so that it can generate you that. But that is a manual task and we don't want to do that. We want to create an automatic pipeline to perform this task. And before we go ahead, so what is our main goal here? Our main goal here is to detect change in semantics. So that's what we assume in this case, that whenever there is a change in semantics, we detect that as a new topic. So how are we going to do that? So first of all, we are going to chunk it. Chunking means we're going to divide this particular text into manageable size of chunk. I use the LangChain library and from there recursive text splitter. So first I imported some library which we have been importing like Llama and everything. But the important part is here. So yeah, identify the key topics. Don't worry, this entire Jupyter notebook, I'll make it available in my GitHub repository so you can go and follow along. So for example, this is my entire transcript of the video without timestamp. And this is the subtitles, which is transcription with timestamp. This both can be generated using Whisper model. After that, I use from the LangChain, I use recursive character text splitter. So it basically split our text into 500 character chunks. With 500 character chunks, I got total 42 different chunks. And here you see there are different chunks and the text within them. So after we divide our entire text into several chunks, our goal is to know from which chunk to which chunk there is a big shift in the semantics or the topic changes. So how we can do that? Using the cross-encoder. So cross-encoder is nothing but it takes two different sentences as input and gives us the similarity score. The similarity score ranges between -infinity to +infinity. But the higher the similarity score is, there is more chance of they being similar. For example, here, say, who wrote To Kill a Mockingbird? And there is another sentence, To Kill a Mockingbird. It's a novel by Harper Lee published in 1960. So you see, when you pass this query and the document, you get a similarity score because they are pretty similar. So you get 0.96, a high similarity score. Something like this. So this method we are going to use. So here there is a big assumption that if two chunks are not related, then we'll have a very low similarity score, and based on that we are going to separate our chunks based on the semantics. So how we are going to do that? For example, let's say this is our first chunk. We'll pass this first chunk into the cross-encoder and we'll obtain similarity with respect to all the other chunks. For example, here you see, so with respect to the second chunk, we get this similarity score. With respect to third, we get this similarity score. With respect to fourth, we get this similarity score. With respect to fifth, we got this. And with respect to sixth, we got a very low similarity score. So we can assume that on the sixth chunk, the semantics has changed and or deviated a long way from the starting chunk. So what we'll do at this point, that we'll take this as our reference chunk and we'll start doing the same thing. And when for this chunk, the similarity will drop from the given threshold, we'll declare, okay, now there is a change in topic. So I have implemented this logic in this particular function. See, find new script from transcript. So what it does, it starts with the first chunk and checks for the similarity score. If the similarity score is less than a given threshold, then it assigns the reference chunk to be the new, it assigns the new chunk as a reference chunk, and we do the same process. So after I did that, I find that we got, total how many? Total 16 different chunks. That means total different 16 times we saw a change in topic. So now we have 11 chunks that we know that at this 11 chunks, we find a change in semantics. Now, as our goal is to obtain this timestamps, now we'll use the subtitle. So now our goal is to match this text with the timestamps in the subtitle. For example, let's say here, for the first chunk, hello everyone and welcome back to my channel. This is going to be the long form of this video, whatever it is. We're gonna match this with all the thing we have in our subtitle. So it matched with the first one, and this is going to be our starting timestamp. Then for the second chunk, we are going to load our language model and blah, blah, blah. That matches with the fifth one, with the fifth transcript here, that firstly we are going to load our language model. So this particular one going to be the 0.31. This is going to be the timestamp for this one, for this particular chunk. And we're going to do that for the entire 11 chunks. And for this similarity matching also, I'm using the same cross-encoder. Here, one question may come to mind, that why not just use this particular transcript? We can just pass this, we can just use this as one chunk, this as the second chunk, this as the third chunk. So I tried that, but it doesn't work because the context line is not very long. Here the context line is pretty small compared to here, and sometimes it's difficult to make sense. When I tried to use this as my chunks, my one chunk, and I tried to do the similarity score, it was very abrupt. So I tried that, but this method worked better. Of course, it took more computation and little more complex, but it gives inherently better result. So after doing that, what we achieved is we got the text and along with the starting timestamp. And here we get, I think, 15 or 16 of such timestamp. Not all of them will be relevant, but that's for you to decide. But there is still one thing is lacking here is, for example, look here. This is the raw text from the video. It's not a very useful thing to refer to a chapter. Rather, we want a very shorter and crisper description of our chapter. And in this case, what we are going to use? We are going to use the large language model to basically create the meaningful chapter heading. And in the next step, that's exactly what I did. So we use the LLM to rephrase the timestamp. So here is my system prompt to the LLM that rephrase this chapter name to make it look like a standalone video title. The sentence should be easily understandable and concise, not more than 60 characters. Do not include any additional text or numbering. Here is the rephrased version of the chapter title. So let me show you how I did that in the code. This is the part where I searched through my subtitles to match with the timestamp. And this is my rephrasing part where I just created this small function that takes in the raw chapter text, something like this, and converts it into a useful and crisp title. And I just, loop through all of my timestamp and do individually. And see, this is what I get. So I get building a Gita rack application to combat LLM hallucination. Okay, that's fairly good. Understanding PDA library implementation. And after that, we got our corresponding timestamp and the topic header. And this is all done automatically in like couple of clicks. It doesn't take more than 1 minute to do this. Otherwise, usually you have to watch through the entire video to put the timestamps on. With that said, let's verify whether this is good or not. For example, let's say this one, 1 minute 13 seconds. So now let me play. Now it's 1 minute 11 seconds. Bits and bytes config. So what they offer is that you can, instead of 16 bits floating point, you can use 8-bit precision. So yes, it indeed talk about optimization and quantization of the model. So let's check another part, the 13.23. I'm asking it to convert it into PyTorch tensor, and I'm normalizing the embeddings, and then I'm saving it as vector embedding.pt, so that when I'm doing my inference, I can directly load this vector embeddings. So you see, at this time I'm talking about loading vector embedding, and it did refer in a correct way. So in order to summarize, it generates a lot of different chapters, but maybe all of them are not useful. It, for a totally automatic manner, it does a pretty good job. And yeah, that was all about this video. In the next video, I'm going to talk about advanced RAG method. If you're interested in that, then do like and subscribe to this channel. See you in the next video. Until then, stay curious.